Hi students. This is obviously, I keep saying this is Miss Norwood like you guys don't know. It's nice to be with you guys again. I just want to address that if you think I ran out of math shirts, I did not. This one says all you need is love, and the love are all these equations, so just saying. So we are going to practice the ellipse some more today. So the first thing we're going to do is I'm going to write the equation of an ellipse. I'll have to get my pen. Okay, so right here on the board, or on your paper, I want you guys to write down x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. Okay, so we've never done an ellipse equation that looks like this, but if you remember the parabola, we did do one that looks like this. And if you look at the equation, like, you guys should be able to tell me that this is definitely not a parabola. Okay, even though it might look weird. And the reason you should say that is because in a parabola, you couldn't possibly have y squared and x squared. So if you have both y and x squared, that's how you know it's an ellipse, okay? So our goal for this problem is to get this problem to look like the ones we did yesterday, because the ones we did yesterday are easy to graph, okay? So here's the thing. With an ellipse, you want all the variables on one side, and the only thing you're going to have over here is the number 1. Because remember, the formula has x's and then y's and then equals 1. Okay? So let's regroup this. We always put the x's first, so x squared plus 6x. Then we put the y's, so 4y squared minus 8y. And the only thing we want on the right side is just the number. So in this case, we had to subtract the 9 to the other side. Okay. All right, remember in the parabola how we completed the square? Okay, we're gonna have to do that twice for this problem. So we're gonna do it for the x and we're gonna do it for the y. Okay, so let's just fix this up a little. We're gonna do x squared plus 6x plus some number to make that factorable. Okay, then here you have to take the 4 out. You're not allowed to complete the square if there's a number in front of y squared. And then you take that out of both of those y terms, so it becomes this. Okay, so the 4, like when you re-multiply this, you should get this back. So 4y squared minus 8y. Okay, all right. So this is where you want to add those numbers. Okay, so remember the trick is you take half of this, which is 3, you square it, and you get 9. And remember the point of that is now this factors perfectly, okay? Here you take half, don't worry about the 4 yet, take half of this number, which is -1, square it, and you get +1. Okay, now this part's a little tricky. Okay, we have to balance this equation. I added 9, so I have to add 9. But here I didn't add 1 because everything in here is being multiplied by 4. So I actually added 4, so I have to balance this by adding 4. So just be really careful about that part, okay? All right, so now both of these are factorable. So this factors into x plus 3 squared. This factors into y minus 1 squared. And then -9 plus 9 plus 4 is 4. Okay, all right, so an ellipse has to equal 1. So whatever number is right here, you're just going to simply divide every single term by that. Okay, so you're left with x plus 3 squared over 4 plus, these 4's cancel, y minus 1 squared over 1 equals 1. Okay, so now that looks like the homework you did yesterday, so we are going to graph this now just for practice. Okay, so remember the first thing you do when you graph an ellipse is you find the center, which is -3, 1. Okay, opposite of that, opposite of that. Okay. So draw yourself a nice graph. You're going to plot the point -3, 1. And I'm going to just put a little C there for center. Okay? All right, and then the next thing is you go in, underneath the x is the number 4. Okay? So that means that you square root this, and so in the x direction, you're going to go 2 out on both sides. So from here, you go 2 out and 2 out. Okay? In the y direction, if you square root 1, you get 1. So you're going to go up 1, down 1. Okay? Up 1, down 1. Notice I made no mentions of A's and B's, okay? So just this is this direction, this is this direction. All right, you draw, and you get this cute little ellipse, it's so small. And then I want you guys, since this is the long side, write vertices. This is the short side, write co-vertices. And remember, since those fall on really nice points, you don't have to like label those. Like you don't have to say that that's -1, 1, okay? All right, but you do have to find the foci every time. So remember, the big number equals the small number plus c squared. So 3 equals c squared. Okay, so c equals the square root of 3. That's the distance from the center to the foci, okay? So remember, the foci are always in the same direction as the vertices. Root 3 is less than 2 but bigger than 1. So I'm going to go out in between 1 and 2, put a foci, in between 1 and 2, put a foci. Those I do have to label because they fall at weird spots, okay? So if you go to label this point, the only thing we know for sure is that this has a height of 1. Like it's clearly at 1. It's really hard to tell this value, so what you have to do is you have to reference it from the center. So this distance right here is our root 3. So from the center, which is -3, you add root 3 to get to here, and then it has a y value of 1. Okay, so again, you're here. We know this is -3. This is root 3 bigger than that. This one is root 3 smaller than that. So this is also root 3. Okay, so then this point is -3 minus root 3, comma 1. Okay, all right. So we're going to do another problem just like this. If you feel good about this, I would encourage you to, after I write it down, try the problem on your own. And then if you think you got it right, you can just fast forward me through until the answer. If you need me to step through it step by step, then obviously I'm going to do that also. Okay? All right. Okay, so the next problem is going to be this. 4x squared plus 3y squared plus 8x minus 12y plus 4 equals 0. Okay, make sure I wrote it down right. 4x, okay, great. Okay, so same thing as before. We're going to get all our x's first, all our y's second, number on the right, okay? So our x's are 4x squared plus 8x. Our y's are 3y squared minus 12y. And then this I subtract and I put that on the other side, okay? All right, and remember, you're not allowed to have coefficients in the front, so I have to factor that 4 out. So 4 times x squared plus 2x. I only factor the 4 out of the x terms. And then I'm going to leave a little space to complete the square. Okay, here I have to take a 3 out. Okay, leave a little space to complete the square. Okay, sorry, I'm running out of space over there. Okay, so take the 4 out of here. You get to take a 4 out of here, a 3 out of here, and you're left with 4. Okay, all right, then to complete the square, okay, take half of this and square it, you get 1. Take half of this and square it, and you get 4. Okay, now the benefit of that is now both of those things are factorable, so you get 4 times x plus 1 squared plus 3 times y minus 2 squared equals -4. Okay, here's the part where you have to do the balancing. Okay, and I could have done it before. You didn't add 1, you added 4. Okay, you didn't add 4, you added 12. So remember, when you add a number in here, you're tripling all of these terms. Here, you're quadrupling all those terms. You have to account for that, okay? All right, so when you add all those up, you get 4x plus 1 squared plus 3 times y minus 2 squared. -4 plus 4 plus 12 is 12. Okay, and remember, in ellipse, we always want this to be 1. So divide by 12, divide by 12, divide by 12. Okay, these numbers are going to be reducible. So this is x plus 1 squared over 3, okay, plus y minus 2 squared over 4 equals 1. Okay, all right. So now we're going to go ahead and graph that. Okay, so draw yourself an axis. Okay, all right. So remember, the first thing you do is you always find the center. Center is the opposite x, opposite y. So -1, 2. In the x direction, you're going to go out root 3. So root 3 is like 1.5-ish. Okay. In the y direction, you're going to go up and down 2 because that's the square root. So 2 and 2. These ellipses are small today. Okay. This problem, draw that a little bit better. In this problem, it's taller than it is wide. So this is a vertex, a covertex, a covertex. Okay. All right, so the foci, remember, are always in the direction of the vertices. So there's going to be foci like here and here, okay? To find them, you take the big number, 4, set it equal to the small number, 3, add c squared, so subtract, and you get that c equals 1, which means that the foci are up 1, down 1. Okay, so these all fall in really nice spots. I do not need to worry about that. These I do have to write. So this point right here has a height of 2, and this is root 3. So from -1, I add root 3, height of 2. Okay, this one, from -1, I subtract root 3, height of 2. All right, so hopefully this is going okay. We're going to do one more thing with the ellipse today, okay? I'm going to give you some stuff, like some information, and we're going to write the equation, okay? All right, and again, I do recommend you graphing this. It just really helps write the equation. Okay, so we're going to do 2 examples of this. I'm going to walk you through, and the other one you can try on your own if you want, okay? Okay, so this problem says write an equation of an ellipse, okay, with, and then I'm going to give you some information. It has a center of -3, 1, a vertex of -3, 4, and a focus at -3, 0. Okay, all right. So let's go ahead and just like plot that stuff. So -3, 1, center. Okay, -3, 1, 2, 3, 4, vertex. I would highly recommend labeling those. Focus, -3, 0. Focus. Okay. So here's the thing. You have to know that everything is really, really symmetrical. So I'm going to put in a different color the things that I add, okay? So if we have a center and we have a focus 1 down, we have to have a focus 1 up from that too, okay? If we have a vertex 1, 2, 3 up, we have to have a vertex 1, 2, 3 down, okay? So those are the things that have to be true, okay? So we know how tall our ellipse is. We know where the foci is. The only thing we don't know is how wide it is. This is where you're going to use this equation, okay? So we've been using this, but every single time we've used it so far, we've known these two, we've used it to find this, but now this is a little bit different. Okay, we know this is taller than it is wide because these are called vertices. So we know that 1, 2, 3 is the distance from the center to the vertex. We know that's the biggest number in this problem, okay? So we know that this number is 3. Okay, it has to be the biggest, otherwise these would not be called vertices, okay? We know the distance to the focus is 1. Okay, so 9 equals b squared plus 1. 8 equals b squared. Okay, in our equation, I will just use that, because remember the equation has b squared in it, but to actually find the distance, I would square root this, and I'd get 2 root 2. Which tells me that my width is root 8, which is just less than root 9, so it's just less than 3, so you're going to go out a little less than 3. Okay? Those are going to be your co-vertices. Okay? So co-vertice, co-vertice. Okay. All right, it didn't actually say to graph it, but I just figured we would graph it since we had almost all of it. Now what it really says is to find the equation, okay? So to find the equation, you need to have the center is really important. It was given to us, so that's kind of nice, -3, 1. Okay, that's going to do the whole top of your equation for you. So you're going to do x plus 3 squared plus y minus 1 squared equals 1. Okay, so basically just by having the center, you have the whole top of your equation. Then underneath the x, you go, how wide is my ellipse? Well, we know that this is root 8, okay? And then you square that, so you get 8, okay? How tall is it? It's 3 tall, and then you square that, and you get 9. So this is the width, this is the height, there's your equation, okay? All right, so I'm gonna put up one more problem, and again, you can try it on your own, and then fast forward to the answer, or you can have me walk you through it, okay? All right, so. So in this problem, I'm gonna give you foci at 1, 2, and -3, 2, and a vertex. Man, my board will not stay on this wall, this tape. Okay. Vertex at, oh gosh, I can't read my handwriting. It looks like it says 5, 2. Hold on, let me just count. 1, 2, 3, 4, 5, yeah. Okay. All right, so this is our information. Again, I strongly encourage you to take this information, even if it doesn't say to graph it, and plot it on a graph, okay? So foci is 1, 2, okay, and -3, 2. I'm gonna label those foci, foci, okay? Vertex is 1, 2, 3, 4, 5, 2, vertex, okay. All right, so here's the things that we know for sure. If foci and vertices are this way, okay, the only possible thing would be for the center to be right in the middle, because everything has to be super symmetrical. So I know that this is my center, which is 2 from this focus and 2 from this focus. So now I also know, which is really important, that my center is at -1, 2. All right. Also, if there's a vertex 1, 2, 3, 4, 5, 6 away, then there's also 1, 2, 3, 4, 5, 6 away over here. So this is my other vertex, okay? All right, I know this is the long side. My only job now is to find the height, okay? 1, 2, 3, 4, 5, 6. This has to be the biggest number in the problem, right? Because it's obviously bigger than this and it's bigger than this. Otherwise, these would be called vertices. So this distance right here, which is 6, is the biggest variable, which is why I put it over here by itself. So remember, hold on, let me just write this down again. A squared equals B squared plus C squared. The biggest variable has to be 6, okay? We don't know how tall it is, okay, but we do know that the distance to the foci is 2, so that is going to be our equation. 36 equals B squared plus 4. 32 equals B squared. We'll use this in our equation, but to actually find the height, you need to square root that, okay? And then you should reduce this, okay? So this is 16 and 2, so this is 4 root 2. Okay, all right, so 4 root 2 is kind of hard to approximate, but root 32 is not. Root 32 is less than 6, okay? And bigger than 5, obviously. So you're gonna go 1, 2, 3, 4, 5 and a half-ish. 1, 2, 3, 4, 5 and a half-ish. Those are your co-vertices, okay? And then this is kind of a big ellipse. They're hard for me to draw when they're big, but let's see how I do. Oh, not bad. Okay, all right, so remember, if I asked you to graph, I would want you to write these points on, and we can do that for practice in a minute, but the actual answer is just what is the equation, so I guess it's a little optional whether you mark all these, okay? If you did, though, you would say that this point is -1, and then from the center, which is at 2, you go up 4 root 2, and this point is you go over 1, and then from the center, which is at 2, you go down 4 root 2. So you can just practice doing those, okay? All right, so my equation is x minus the x part of the center, so x plus 1, okay, plus, and then y minus the y part of the center, so y minus 2. Don't forget that 1 there, okay? And then underneath the x is how wide is it in the x direction. We already know that it's 6, so you square that and you get 36. How tall is it? We figured that out here. It's 4 root 2 tall, but you have to square that, so you get 32. And there is your equation. All right, so try your homework, look at the answer key if that helps. Email me if you have any questions. Tomorrow we're starting applications of the ellipse. So it's really important that you guys have like all this foundation stuff solid before we start that. All right, hope you guys are still doing okay. It's been like a week and a half, so hopefully you're getting a lot of sleep, and I love you guys. Bye, take care.